Hi, sixth grade. Today we are going to start off with a reading selection that's a little bit different. I don't feel that your book does a very nice job of explaining why changes of state occur. So I kind of put together an article of my own that I figured we could read. So you have this in your changes of state folder if you want to pull it up, or you can just follow along on my screen as well. So if we preview, we are going to be talking about the motion of particles. And we see atoms and molecules are in motion, which we knew that from our last section. We're going to be talking about thermal energy. So stop right now and kind of think back, what do you remember about thermal energy that we had already studied previously in the year? And then we're going to be talking about how is temperature and thermal energy related, and then what's next? How is this all going to relate to what's happening in our selection now? So looking up at the top, we warm things up and cool things down all the time, but we usually don't think about what's really happening. By now you know that substances are made of atoms and molecules. These atoms and molecules are always in motion, and we talked about that when you had to compare and contrast solids, liquids, and gases. The big comparison, all of those molecules are in motion, it's just how they move is different. So what causes these particles to be in motion? Think back to our study of energy. What are the two main types of energy? You should be thinking kinetic and potential. Which type is the energy of motion? Should be thinking kinetic. If the speed of the object increases, its kinetic energy increases. If the speed of the object decreases, its kinetic energy decreases. So if the atoms or molecules of a substance are moving fast, they have more kinetic energy than when they are moving more slowly. The question is, how do we speed up or slow down particles? So let's just start off with our notes here. So changing of states of matter, you need to put your date, and then we are going to say motion of particles. And so we know from reading that the reason why they're able to move is because of the kinetic energy that they have. So particles are always moving. They can move because of their kinetic energy. So, and then I'm going to kind of tab over and say moving faster equals more kinetic energy. Okay, going back to our reading. Thermal energy. We learned that there are many different forms of kinetic energy. Can you think back to what those different forms are? One form was thermal energy. Moving atoms and molecules have energy. The energy of these moving particles is thermal energy. You have already studied the movement of the particles in solids, liquids, and gases. What state of matter do you think has the most thermal energy, and which state of the matter has the least? Why do you think this? So I actually want you to stop right now and actually just like on a separate sheet of paper, scrap paper, or a section in your notes, put which one do you think has the most thermal energy and why, and then work your way down to the least. So go ahead, pause the video and do that. Okay, now that we're finished, let's come back and say, okay, solids would have the least thermal energy and gases would have the most. Throughout this section, you will hear either kinetic energy or thermal energy when we are describing the energy of those particles. And one thing that I really want to kind of point out here is that we say that gas is moving very quickly, but the gas, depending on the temperature that it's at, can actually be changing. So before we kind of jump into how it can change, let's stop and get some notes on thermal energy. So thermal energy. Energy of moving particles. That's really all we need to take from that there. And I might say, solids have the least and gases have the most. So how is temperature and thermal energy related? Temperature is a measure of the average kinetic energy of the atoms or molecules of a substance, or thermal energy. By taking the temperature of something, you are actually getting information about the kinetic energy of its atoms and molecules. If the temperature is high, the particles have more kinetic or thermal energy. If the temperature is low, the particles have less kinetic or thermal energy. So if we look here too, I put a picture of a thermometer here with the Celsius and Fahrenheit representations here. We in the United States, we use Fahrenheit, but the rest of the world and scientists, they use Celsius. So I thought that this might be a nice resource for you guys to have. When you're seeing a lot of Celsius degrees, what does that equate to? So the big thing is 32 degrees Fahrenheit is the same as 0 degrees Celsius. So let's add this to our notes, and then I want to actually show you a little simulation. Temperature. The measure of the average kinetic energy of the particles in a substance. Now, it says average, so I want you guys to realize that when we're in a gas, not all of the particles are speeding around at the exact same speed. Some are faster, some are slower, but this is what the majority of the particles, how much energy do they have. So if we look at this next little section that I have, I just want to give you an idea of how the particles can change when we heat them up or cool them down. Okay, so what happens is as soon as we increase the temperature, that doesn't necessarily mean that we're going to have a change in state, or as soon as we decrease the temperature that it's magically going to change state. It has to reach a certain temperature or a certain point. So we can actually heat or cool a liquid to speed up the particles or slow them down. So here's heating and cooling a liquid. So if you see, okay, this is how kind of quickly the particles are moving when it's cold. And then if we heat it up, you can see that they're starting to move faster. But they're still not moving fast enough yet to turn into a gas. Or when we decrease the amount of thermal energy, they move slower, but still they're not in those fixed positions to be a solid. So I just want you to be aware that these particles can move faster or slower depending on how warm or cold it is. So what causes the change of state, or what causes the particles to move or change their speed, is increasing or decreasing that thermal energy. So I want to add that as a note here. So we're actually going to cause changes of state to happen by increasing or decreasing the amount of thermal energy. And that's a very important point. We're going to be looking at each change of state, and are we increasing or decreasing the thermal energy, and then what effect is that having on the particles. So as you're going through each station, or kind of each note segment and each investigation, I really want you to be focusing on, is there an increase in thermal energy or decrease, and then what does that cause the particles to start to do. The other thing that I want to show you has to do with thermometers. And so you can see the heating and cooling of a thermometer. Now, our thermometers used to be filled with mercury, but mercury is hazardous to us. So now it's actually filled with alcohol that is dyed red. So at room temperature, here are the liquid, or the particles in a liquid. As we put that thermometer into a substance that has a lot of thermal energy to it, it gets hotter. And so you can see that the liquid expands because the particles are moving faster and start to spread out a little bit more. Now, they haven't reached a gas state yet, obviously, but we know that going from a liquid to a solid, the particles spread out. So as it gets hotter, those liquids are going to spread out, those particles in the liquid. If we go back to room temperature, we can see how the thermometer goes down, and they get closer together and slow down a little bit. And if it gets colder, they get even closer together, and they're just moving around a little bit, so we see that the liquid also goes down. So I just wanted to kind of show you that this is what the particles are kind of looking like as we're adding thermal energy or decreasing thermal energy, because this is what we're really going to be focusing on in this section. The other things that I really wanted you to kind of be focusing on as we're moving ahead, there are some terms that you want to be aware of that I might be using in some of your questions. The first one is at the molecular level. When I say molecular level, let's just kind of type that out. You can see there's the word molecule in it. So molecular level just means at the level of molecules. So you're going to explain to me what's happening with the molecules. You're going to hear the word molecular a lot. So I just kind of want to point that out as we're going through. Now you guys can go ahead and move on to the next step in your to-do list.